Hello, Assalamualaikum and very good morning to everyone. So in this video I would like to explain about what is the degree of dissociation. Okay, so before that let me explain about the degree of dissociation. So first of all, what is the degree of dissociation? So let's say we have an equation. So A produce B. We know that the amount of the product B formed is depend on the amount of A dissociate to produce B. So because of that, we calculate the degree of dissociation for the reactant only. Alright. So degree of dissociation can be expressed in two ways. So the first one, we call it as a degree of dissociation. The symbol is alpha. Okay, and the formula is the concentration change or dissociate over the concentration initial. If all the reactant converted to the product, or if all the reactant dissociate, so we can have the degree of dissociation, which is the maximum is 1. Okay, that is the first technique. The second way to express the degree of dissociation is by using percentage dissociate. So the percentage dissociate, the formula is still the same. The concentration dissociate or change over the concentration initial. Okay, because we want the answer in percentage, we need to time 100%. So the maximum is 100, meaning that if you have 100 degree of dissociation, means that all your reactant converted to a product. So in that situation, it is no more a reversible reaction. Usually, if it is 100% dissociate, it is on one direction only. Okay, so that is the idea or the definition of the degree of dissociation. Now let's look at this question. This is our tutorial question number 10. Okay, so if we look at the question, dia kata the nitrosyl bromide decomposes to form a nitrogen monoxide and bromine according to the equation. If 2 mole of nitrosyl bromide in 1 liter flask decomposes to give 0.09 mole bromine at equilibrium. So this is the point. 0.09 is the number of mole at equilibrium, and 2 mole is the number of mole initial. So because we have a changes like that, how to calculate the Kc and Kp? Alright, so I will rewrite the equation. So the reaction is between 2 nitrosyl bromide produce 2 mole of nitrogen monoxide and 1 mole of bromine gas. So the information given is the mole initial, which is 2.0 mole, and at the beginning of the reaction there is no information for the product. Okay, so because we have the data for the concentration, the data at equilibrium, so that we have to decide whether we want to tabulate an ice table for mole, concentration or partial pressure, because we have 3 types. So partial pressure is not suitable here because we don't have any data for pressure. So between mole or equilibrium concentration, so I prefer to choose mole for our ice table because the data at equilibrium given is term of mole. So in this case, we use mole as our ice table. So mole initial, and then we have mole change, which is negative 2x. This is gain 2x, and this is we gain x. And the mole at equilibrium 2.0 minus 2x. This is 2x and this one is x. If we look at the question, there is a statement mentioned that the number of mole bromine at equilibrium is 0.09. So means that we can put the value here. So automatically we can say that the value of x is equal to 0.09. So that we can insert the value here and also here. So from there you can get the number of mole, which is 1.82 mole, 0.18 mole and 0.09 mole. Okay, but if we want to calculate the Kc, okay, so let me write the Kc expression first. NO, nitrogen monoxide squared, Br2 over NO Br. The requirement of the formula is concentration, but we have a data in the form of mole, so that we can calculate the concentration at equilibrium by dividing with the molar volume, which is 1 liter, 2 molar. This is 0.18 molar and 0.09 molar because the volume is equal to 1. So in this case, alright, so finally when you insert the value, you're supposed to get the value of Kc, which is 8.810 to the power of negative 4. Okay, and then we want to determine the value of Kp. So there is one formula that relates the Kp and Kc. So Kp is equal to Kc RT delta N. So the value of Kc is already given, which is already calculated. Okay, R is 0.08206. T is your temperature in Kelvin. We have 77, which is 350.15. Okay, 1 refer to, okay, if we look at our equation, this is 1, this is 2. So the total is equal to 3. And this is 2. So that the delta N is equal to 3 minus 2 equal to 1. So that our delta N is 1. And finally, we're supposed to get the final answer for Kp is 0.025. Okay. Alright. The next question, which is B. So the question asks you to determine the degree of dissociation, NO Br. Okay, if we write the formula, so for B, degree of dissociation, which refer to alpha, concentration dissociate or change over the concentration initial. This is for NO Br, nitrosyl bromide. If we look at our ICE table, this is the mole initial and this is the mole change. Okay, so we already have the mole initial, which is 2 mole. If we want to convert to concentration initial, it becomes 2.0 molar. The concentration change is 2x, which is 2 times 0.09 becomes 0.18 mole. So it is equal to 0.18 molar. So that we can replace the value 0.18 molar because the formula required the value in mole concentration over 2.0, so that the molar will cancel off. Finally, you're supposed to get 0.09. based on this value, we can say that only small amount of the nitrosyl bromide dissociate to produce a product. Why I said that? Because the maximum is 1, but we only have 0.09, which is a very small amount. Right? So I hope that you understand about the dissociation, degree of the dissociation. Okay, thank you very much.